Welcome to Circuit Masterclass, your go-to channel for everything in power systems, transmission, and distribution engineering. Don't forget to check out circuitmasterclass.com for in-depth blogs and bonus content. We have provided the website link below in the description. Let's get started. I am going to discuss the first pole to clear factor of a circuit breaker. This is a very important parameter of a circuit breaker. We often find this factor written on the rating plate of a circuit breaker, especially in 33 kilovolt circuit breakers, whether it is an SF6 or vacuum circuit breaker. Typically, the first pole to clear factor is written as 1.5 on the rating plate. For 132 kilovolts and above, this factor is written as 1.3 on the rating plate of the circuit breaker. Now, we will explain the detailed theoretical background of this factor in this video. Many of us do not have a clear concept of the first pole to clear factor, which we aim to clarify here. There are three waveforms representing a three-phase alternating current system. These are the current waveforms. Suppose this is the waveform of the red phase current, as highlighted in the image. Next, this is the yellow phase current, and this one is the blue phase current. We all know that the phase difference, or more precisely, the phase angle between the currents in a three-phase system, is ideally 120 degrees. Here, you can see that the angle between the red phase and yellow phase currents is 120 degrees. That is, the red phase starts here, and the yellow phase starts after 120 degrees. Similarly, the angular difference between the yellow and blue phases is again 120 degrees, and after another 120 degrees, the red phase crosses zero again. Now, consider a three-phase circuit breaker that has three poles, each pole connected to one phase of the system. Let's assume this is the fixed and moving contact assembly of a circuit breaker for the red phase pole. This is the yellow phase pole, and this is the blue phase pole. We are not going to show the entire circuit breaker structure here. We are only showing the context for better understanding. Now, let's say at a certain moment, the circuit breaker initiates the opening operation. Suppose, at a certain moment, all three poles of the circuit breaker open simultaneously since the circuit breaker is gang operated. However, at that instant, arcing continues in each contact gap, so the current continues to flow through the gaps. Let's now consider the red phase for better understanding, and then we'll discuss how current is interrupted in the yellow and blue phases one by one. This is the current waveform, indicated by a glowing line. At this point, the current has reached zero crossing and is interrupted. This results in the appearance of a restriking voltage across the contacts at the instant of current interruption. Let's say the red phase current is the first to be interrupted in this case. Now, although the red phase current is interrupted, the yellow and blue phase currents still continue. Eventually, when the blue phase current reaches its zero crossing, as indicated by the glowing blue curve, it too is interrupted, and another restriking voltage appears. So now, the blue phase current and the red phase current have been interrupted, but arcing still continues in the yellow phase. Finally, the yellow phase current is interrupted at its zero crossing, and a restriking voltage appears across the yellow phase pole contacts. At this point, all three arcs are extinguished, and the current is finally interrupted in all phases. Now, the voltage waveform is established across the contacts of the circuit breaker in all three phases. From this diagram, you can observe that the restriking voltage appearing across the open contacts of the red phase pole is the maximum, because in our case, the red pole has interrupted the current first. Therefore, the restriking voltage across it is the highest, compared to that across the blue and yellow poles. Definition of first pole to clear factor. The first pole to clear factor is defined as the ratio of the highest restriking voltage to the phase to ground voltage. First pole to clear factor equals highest restriking voltage divided by phase to ground voltage, where the highest restriking voltage occurs across the contacts of the first pole to interrupt the current. Here is the phase to ground voltage after full interruption.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic, leave a comment. Thank you.